In this video, we will cover how to factor trinomials in the form of x squared plus bx plus c, where b and x are constants, or they are numbers. So first thing you want to do always when your prompt is to factor a polynomial, whether it's a trinomial or anything, is to factor out a GCF if possible. So if we look at our example below the box here, factor x squared plus 13x plus 30, we don't have a GCF other than 1, right? X squared, there's no factors of, if x squared's here, we don't have an x squared here, so we can't factor out our variable factor. And of our constants, or our coefficients, we have 1, an invisible 1 right here. 1, 13, and 30 share no common factors other than 1. So we can skip this part for this example, right? We don't have a GCF. So we go to step 2. And what we want to do is we want to find two numbers whose product is C. So see how C is this last piece of the trinomial. We want to find two numbers whose product is C, but whose sum, so whose product is C, but whose sum is B. So our B is the coefficient of our x term. We want to find two numbers when multiplied equal C, but when added give us B, right? So it's helpful here to make a list. So if I always write my C term, this 30, and think of two numbers when multiplied that can give me 30, right? Two numbers when multiplied give me 30. And I like going by pattern. I know you guys know that about me by now, but like 1 and 30 are factors, right? 1 times 30 is 30. 2 times 15, right? 3 times 10. 5 times 6. I could do 6 times 5, but I would start mirroring that image then, right? And get 10 times 3, 15 times 2, and 30 times 1. So these are all my factors of 30. These are factor pairs that equal 30, right? I want to find two numbers whose product is 30, but when added, right? When added, give me 13, or the coefficient of x. So 1 plus 30 is 31, so that's not 13. 2 plus 15 gives me 17, not 13, right? 3 plus 10, that gives me 13. So these are the two numbers that I want to factor this trinomial into. So doing this side work really helps. Actually, I probably should have mentioned I like to lay it out like so first, where you're kind of just outlining it, because eventually you guys are going to get so good at this, you're not going to have to do this side work. Sometimes you will, but I bet you sometimes you won't. So what I suggest here is to, what I just highlighted in purple here, this x plus something times x plus something, I like laying that out right away. Just kind of setting up two brackets there. And if you're a trinomial, if this first term is just x squared, or any variable squared without a coefficient, the first terms in each binomial will automatically be x. Right? We're going to check this using multiplying binomials, what we did in our last learning plan. But this can help us see that x times x, if I were to start multiplying these binomials, x times x gives me this x squared. Right? So now where this comes in, this 3 and 10, we're going to enter those numbers in right here. 1's a 3 and 1's a 10. So I just have plus 3 plus 10. Now if I check this using my knowledge of multiplying binomials, again, there's multiple ways to do this. I'm just going to use the distributive property twice. So here I have x times x is x squared. X times a positive 10 is 10x. Positive 3 times x is 3x. And 3 times 10 is 30. Combine like terms. So I have x squared plus 13x plus 30. Right? That's my original. So I know I'm right, right? So my answer to this prompt of factoring x squared plus 13x plus 30 is x plus 3 times x plus 10. Okay. This is a huge GED topic. I would venture to say anywhere from 4 to 6 GED questions will be about factoring and or multiplying binomials, our last learning plan. But if you really have a good understanding of multiplying binomials, this is, you're unraveling it, right? We're taking a sum of terms and changing it into a factor of products, this being one factor and x plus 10 being the other factor. Okay. Let's work through some more examples. The more you do it, the more comfortable you'll be. So again, we want numbers when multiplied give me 7, but when added give me 8. Okay, so the factors of 7 are pretty minimal, right? It's just 1 and 7. So again, I suggest you set up your parentheses like so. And let's just look at this first term of b squared. So what times what gives me b squared, right? And that's b times b, right? Now I'm asking what times what gives me 7, but when added gives me 8, right? So we have 7 and 1. Those are the only factors of 7. So now I put pluses in here because I need a positive 8, right? So if we were to factor this kind of in our head, we have b squared. B times b is, multiply in our head. B times b is b squared. B times 1 is a positive 1b. 7 times b is 7b. And 7 times 1 is 7. So that 1b and 7b that multiply total up to get us this 8b. So the first two examples we went through, the last one and then this one, are all plus signs, right? So they're not so bad. So now notice we have n squared minus 11n plus 10. So this one definitely looks a little bit different, but not much. Okay, so let's first just outline our parentheses. And let's get our first term of each binomial being n, because n times n gives us n squared. So now we have to think of factors of 10 that add to 11, right? Or negative 11 technically. So let's just, I like to ignore the sign for now, just look at 10. So we have 1 times 10, 2 times 5, and that's it. So the only possibility that can even get us close to 11 would be this, right? The 2 and 5 would give us 7, or 3 if we have a different sign. This would give us 11, or if we subtracted them, 9. So this 1 and 10 help us determine what numbers live here. So we have 1 and 10. Now let's think about this here. When I add my middle terms up, if we were to multiply these binomials, I have n times n is n squared. N times 10 is 10n. I realize I don't have signs in here right now. 1 times n is 1n. And 1 times 10 is 10. So whatever goes on here as far as my signs go, I need these two to total a negative 11, right? So I have to have a negative 10 and a negative 1, right? A negative 10 and a negative 1 give me negative 11n, which is what I need, right? So that helps me determine what signs live here. Those are both going to be negatives because I need two negatives in the middle here. Also, I have a positive 10 at the end here, a positive 10, and a negative 1 times a negative 10 gives me a positive 10, right? A negative times a negative gives me a positive. So those definitely take more brain power than the last lesson we did. Even the last problem we did was with our positive terms, but totally doable. Okay, it just takes a lot of practice. Our next one, m squared plus m minus 90. I can set up my parentheses. Can take care of my first term of each binomial, which would be m. Now I need factors of 90, right? Factors of 90 that add up to 1. right? Because remember the coefficient here is 1. So I want to think of two numbers when multiplied that give me 90, but when added or subtracted give me 1. So think about that. Factors of 90, we could have 1 and 90. We could have 2 and 45. We could have 3 and 30. We could have 5 and 8, or 5 and 18, right? A common one would be 9 times 10. And hopefully we make that connection. Okay, 9 times 10. I now need a positive 1 here, right? So that positive lives with my bigger number. That determines that my plus lives here and my minus lives here. Okay? And again, you can always check it. So m times m is m squared. M times 10 is 10m, positive 10m. Negative 9 times m is a negative 9m. And a negative 9 times 10 gives me a negative 90. So if we see here, we have this positive 1m. If I have 10 minus 9m, I match this. I get my positive 1m. And if I take a negative 9 times a positive 10, I get my negative 90, which is also up here. So the m squared plus m minus 90 factored is m minus 9 times m plus 10. Let's look at this next trinomial here. So again, a trinomial, factor out the GCF if you can. If there's no coefficient here and there's no variable here, there's no GCF that you can factor out. So we're kind of skipping that step, but that really should be your first question, is if you can factor GCF out first. In this case, we can't. So we look at this first term of n squared, and that will be n times n. And then I need two numbers when multiplied to give me 12, but when added or subtracted give me 4. So I have 1 and 12, 2 and 6, and 3 and 4. So the only combo that can give me anything close to 4 are these two. Right? If I added 11 and 12, I get 13. If I subtract them, I get 11. If I add 2 and 6, I get 8. If I subtract them, I get 4. Here I can either get 7 or 1 if I add or subtract. So 2 and 6 are what I'm looking for. So I can just place those in my parentheses. Now to determine the sign, I have a positive 4 I need. So that positive has to live with my larger of the two numbers. So my plus has to be here, and my minus has to be here. And you could check these last two terms here. I have a negative 2 and a positive 6, and that gives me negative 12. So I'm on the right track. A couple more together before you practice in IXL. Feel free to pause the video, of course, and try some out. Here, n squared minus 10n plus 9. So I have n and n. And I need numbers that when multiplied give me 9, but add give me 10. So I could choose 3 times 3 or 9 times 1. I'm going to choose 9 times 1 because I need something that gives me 10 in the middle there. So I need a negative 10, so that lives with both. A negative 1 and a negative 9 and a negative 1 give me negative 10. I could also check this last term. A negative 9 times a negative 1 gives me a positive 9. Let's look at our next one. So we have b times b. And now I need factors that when multiplied give me 64, but added give me 16. Just said the answer. So 8 times 8 is 64, and 8 plus 8 gives me 16. These are all positive because they're all positive originally. So that's awesome. Chances of you getting all positives on the test are slim. You're probably going to get more combinations so you know what sign lives where. Next, I have m squared plus 2m minus 24. So let's take care of our first term of each binomial. So now I need factors of 24 that add to 2. So if we were going to make our list, we have 1 times 24, 2 times 12, 3 times 4, 3 times 8, 4 times 6. 5 doesn't go into 24 evenly. 6 does, that'll be 4 again, right? So I get that mirror. So I need 2 factors that when added or subtracted give me 2. So it'll be these two, 4 and 6. Now think about where your signs, what sign goes where, right? So here I have a positive 2m I need, so that has to be with my bigger number. So my plus needs to be with my 6, and my minus needs to be with my 4. All right, last one on this, x squared minus 4x plus 24. So I can do x times x. I already have my list over here for 24, so I'm not going to rewrite it. But I need factors of 24. These are my factors. When multiply, give me 24. That add or subtract to 4. So this can give me 25 or 23, 14 or 10, 5 or 3, or excuse me, 5 or 11, or 2 or 10. So none of those give me 4. So when that happens, this is just a trinomial that can't be factored, right? This in more math terms would be considered prime, right? It has no factors other than itself and 1. So this is prime. I am pretty sure on IXL, if you discover a trinomial that can't be factored, you just have to retype this in again. So that's just a good tip for you guys when you're working in IXL. Again, if it can't be factored into 2 binomials, it might ask you either to click that it's prime, or you would have to type in the exact trinomial that you start with back again. So just be careful for that in IXL. As I stated in the other videos of all this polynomial and factoring of all these topics, again, you can expect 4 to 6 questions on these topics on the GED test. So I've seen at least 2 factoring questions on GED Readies, right? So if you double that, because the GED Ready is half of a test, a real test, you can expect to see 4 factoring questions. Okay? So it's definitely something worthwhile to practice.